Let's see. Okay. So in now we will talk about event-driven architecture. What is event-driven? And then you were thinking like, what is Kafka and how we use microservices even is so microservices when we use is not just like we covered this a little bit of the CI/CD. You know now what is continuous integration and continuous delivery or deployment. When they say delivery and deployment, it's just same thing. Just give the same answer. So they have mentioned like continuous delivery here, and you're deploying even in that. So do you have like understanding on continuous integration and delivery now?
Yes. Okay.
Theoretically, what do you like think about it?
Basically, we just automate the deployment process, and this is our we can say project life cycle. We can say which will goes on and on. Whenever there is something there is a crash between any application or any microservice crash, then it will uh, again goes to its initial phase and restart all of the process
No, no, no,
after
no.
the.
Okay, let me tell you. Okay, no, it's not about crash. It's about putting new release on or a feature on production. So like you say you are running, you develop your Node.js application and you develop Node.js application, you're running MongoDB and everything is fine. Now you're running a login feature and you have maybe like developed some website, right? And now maybe you want to update something in that, maybe some database, you want to add more users, or you want to add a feature like on front end, you want to make some changes in UI, right? So you have to make changes in the code. But in production, you can't make changes in the code just on the fly. You will
Mhm.
you will make changes in that. You will put it into the Docker image or like a container image, and which will go to the image registry.
Mhm.
You know image registry like Docker Hub. I was telling you,
Yes, yes.
and there the code will get stored. So the code you updated will get stored, right? And then they usually test it in lab. Then, like with Postman, like you did testing, they will test in lab, and if everything goes fine, all nowhere, all old features are not breaking. There are like test cases. You need to. There will be test cases available for testing old features which are already there. So sometimes when they add new features, it breaks sometimes old features, which also need testing. Like everything in past is we have is working, and then they have to test new features also. For new features, the team need to create new test cases, and then they will test with different automation scripts or any automation framework or with Postman also sometimes, right? And then after everything successful, it's get accepted. Then we will have a release number for that for this new. If so, for example, if using microservice, so if you say account service, inventory service, and shipping service, for example, now you updated, you made code changes in the shipping service, and everything with the QA team or test team worked fine, and they approved it. And now you will update only shipping service in case of microservice, and then no downtime on account and inventory will be there. Only the container currently running for the shipping service will be replaced with the new container that you pushed to the image registry.
Okay.
Did you get like, yeah, is it like too much in detail?
No,
No, right?
I get it. I get it.
You get it right. So this is how the process is. So when they're telling there is no crash happening here, there are cases when, uh, so there are two cases I'll say. Yeah. When new feature they are pushing, they're testing, and then they write the code and they build it into the image registry, and then they will test it and they'll create a release. after everything works fine, and then they deploy it. So and when they're deploying it here, for example, if it's a shipping service, currently there will be a container running and it will replace with the new container, right? And everything stays same. There will be a restart at that time in the, if it's running in Kubernetes, or Docker also have a Docker Compose, but in production now most the company uses Kubernetes. So there will be a restart in the pod, and
Mhm.
then there are ways to avoid that also. I'll tell you that in different session. And the small restart and does not impact other services. And then if you, after the deployment happen, there is a monitoring will be there if it's connecting successfully to the database and all the features are running in production fine. There will be a monitoring that this service have some like API endpoints, right? So you created
Yeah.
APIs
Okay.
similar way for APIs. Some APIs are to like maybe write the data to the database, or to forward the user after successful login to the some page. But some APIs are to give the health information of the service or feature. So service are basically feature in the application, right? When we say service in microservice, like different service, they are basically like one feature. So for example, in this diagram is like this service feature and this inventory feature, and then account. So they can be feature or like a subset of a feature also, because we are trying to split up application into different modules is what basically is,
Different
right?
microservices. Okay.
Yeah. Yeah, that's why they call microservices, because they are basically different modules. Like in the code, we split up into classes and functions, right? And even in like different modules also. Same way here, we are doing it in the architecture way also. Okay.
Okay.
So and then we deploy. So one case I said to update the new features, and the second, like you said, if testing even worked fine, everything is good, but something happened when they put it into the production, or something unexpected happened, just every application was running fine, but some bug triggered, which was not covered during testing. uh, for example, I will tell you a real case scenario which happened in my case. Like there was a there was a meeting app, for example, like Zoom. Okay. And
Okay.
it record the sessions, right? And when it record the sessions, uh, it has to store it somewhere, right? You know S3 bucket in AWS?
AWS. Yeah. Yeah.
Yeah. So in S3, it is storing the recording. Everything is good till then. And now people or host who or like people who were part of the meeting, they get the recording after the meeting is over. Now after a day or two, or after some time, when they're trying to open the recording, the architecture was like it has to retrieve the recording and play it, which is just not like opening a file from S3 bucket. It will need to play that video, right? The recording. When it has to play that, there will be like video encoding happen, and there is something called video transcoding happen. Uh,
Mm.
so that
Yeah.
needs a memory, that needs a resource, memory and CPU. It consume that. It is more than just uh, opening a file or executing some just small application. It is like more a resource hungry process. So for that also, how the architecture was to run a container which will do all these things, which will do all that processing. But what happened in one case is the meeting was too long. Like they had the license and everything for the video, just like Zoom is having like 1 hour for free licensing. But if someone has some paid license, they can run meeting for maybe 5 hours or 10 hours, and they may be consumed like all the hours for that. So that recording file was so big, and when it tried to play on it was just trying to play on the by attendee or someone was trying to play it. The container need more memory for like bigger video, right? So if it's like in
Yeah.
a lot of gigabyte, and maybe they use like HD version or whatever the higher quality version they can use for it, and it crashed because the container, when you deploy the container, you provide sometimes you have option. Either you give limited resource to it. You tell like it can't use more than like uh, so
The one GB and 2 GB, like.
yeah. I was just showing. So you can you have to, for example, in Kubernetes is it is in better way. It's called like CPU limits and request. So so yeah, just to in short, I won't tell more in detail this one. But if the application need more resource, but we have limit that it will use like 500 M. They talk about M. M is like similar to uh, gigahertz, like similar to gigahertz. Uh, so it's an M is megahertz. And then if it is like application trying to use it more, the what happen? Application will crash because uh, it need more resource and you are not providing it, so it will crash. So in that case, basically what happened, I was telling you need to make some changes here. Either you update resources in that, or you need to see if you can do any other workaround. So in that case, also the same CI/CD pipeline will go because you'll create a new release and then you will deploy it, right? So yes,
Yeah.
you were right. And I just wanted to add, so now for CI/CD is basic new deployment process happen in two cases mostly. If it's a bug, we need to have a bug fix quickly, or we need to have find a workaround. But if it's a code related bug, then we need to fix it quickly. And then if it's a new feature, then we'll deploy it, right? Okay.
Yeah. Okay.
All right. So we'll go back to event driven now, right? CI/CD is a little bit covered now, right? We can do lab thing or something later. I just found some random presentation to give you some like definition kind of a thing. And there is a good documentation on IBM also about that. So in short, what happened in event driven is like this shows a better picture. What happened in event driven is, for example, we're talking about event driven in the microservice here, for example. They're talking about this. So what happened? You have multiple services as we saw here, right? Here we have multiple services. So it's not like here it shows we have seen like there's a storefront web app, it says, right? And it says there's an account service, inventory service, and shipping service. But the storefront web app is also kind of a service, right? Right.
Yeah.
So we can say this is also a service. So maybe the flow, if we'll see the client from here will talk to API gateway or this web page on storefront, and then user will user will go to his account, like after login it will go to his account, right? And he can see his orders, their past orders or current orders, something in cart, an inventory, if like his order is in like process, what happened to his current orders which he had already made or paid for it, right? And then here the shipping service, shipping related details, similar way you want to see if something in track in progress, where is it? So here what we see here is we have three services, but the services are talking to another service, like storefront is talking to account service, right? So this is what I'm trying to tell you in event driven. This is very important. So some event is happening. So everything is in the name, event driven. whenever any event is happening, that trigger some other event. One event trigger another event. So for example, user logged in to the web app, it triggered uh, it triggered another service like account service. If user want to go to his account profile or something, if user made an
Okay.
order, if user made an order from his account, the account may talk to
Then
the
then
inventory
it will
also.
goes to then it will goes to the transaction page like that.
Yeah, but what I'm trying to tell you is one service also need to talk to another service sometimes. Account service may not have all the data of inventory service. Well, so inventory service is talking to inventory database, right? But when
Yeah, okay.
you going from account service and trying to get the inventory database, it will account service also sometimes, or like one service sometimes need to retrieve or need to get some data from the another service. So services in conclusion need to talk to each other also. So they're not like completely independent. They may
Mm,
need to communicate with each other, and when one event is happening, it trigger another event. Also, service is talking to another service, right?
yeah,
For example,
fine.
you delivered pizza. For example, I find this also pizza delivery systems. I mean, everything changed with that. This is like simple. I think we'll go with the basic one first, not to make it complicated. Uh, But you see here on when you order the pizza, you see these kind of pictures and something like pizza in progress and something like this. But on the back, as a developer, if you'll see, uh, you should think like this. Oh, this is too small. Maybe this. Yeah. Okay. So you should think like this. Oh, you ordered the pizza like. Uh, yeah, because so everyone using similar API, but the request matters a lot. So one API endpoint is here, API and gateway is there, API gateway is here, but everyone send request to different API, right? Like the customer will send request to give the order, right? But the
Yeah, yeah.
restaurant owner will get the order back. So,
Fetch.
right, different APIs are getting triggered. And when the customer triggered that order API, it will go to the order service, and then order service will tell or forward the request to payment service also, the payment landing page. And before that, customer want to see the menu, and then it is triggering menu service also. And now here you see there is something called messaging queue. What is it? It's very important in event-driven architecture. So the messaging queue is there something which help all the services to talk to each other. So
Yeah,
when you
fine.
ask when you ask what is Kafka, or when you ask when we were here, what is MQQT, there is something called like Rabbit MQ also, if you have heard about it before. And there is also SQS in AWS. SQS is it's queuing service, say maybe sequential queuing service or something. So it's a queuing service. So in all of them, Kafka has multiple purposes, but uh, even in this case, Kafka can be used. But in all the services, if we can see, one common thing is it is queuing the data. So why we need to queue the data? So what happened, like order service for like menu service need to go to order service, right? So what happened in this, they can be like too many people. It's just like not one customer, maybe like 100 customer are ordering at the same time in different restaurant. Like you might be ordering in location A, for one pizza store, but like Domino's Pizza or like Pizza Hut, they have multiple stores but one website. So at one store, maybe 10 customers are giving order at same time, and another time maybe 10 another in another store. In total, maybe there are thousands of people ordering pizza in different stores, and then that what can happen? All the requests are going. They need to be in order. Like you give the order to your nearest location restaurant, so it should go to that only. So to keep that order in sequence also. And what happen if you give the order and maybe for some network interruption or something, your request get lost, like get dropped, and maybe for some reason like the order service or the payment service is busy, and it busy to process other orders, and it won't be able to process your order or payment, and it would just want to wait for some time, so that till that time it will process other orders, right? It's not able to do maybe in multi-threading or multiprocessing way. It does, but it has a limit, right? How many it can process at the same time? If more than that will come, what will happen? Then this messaging queues comes handy, and it uses everywhere when these kind of architectures are there. When microservices is there, even in monolithic, messaging queue is used a lot. So you get the little bit idea, just to set the base to begin with. You get the idea of why we use queuing, to so that if microservices are talking to each other based on event, so queuing can hold those requests
Mm. Yeah,
and
okay. I get that.
send them in order, so that
My request won't get lost in middleware somewhere, middle
yeah,
somewhere.
so that, or also the other services can process the request in order. So it
Mm.
helps to do that. Otherwise, oh, what happened if you're trying to order a service and you're trying to pay and it'll show like timeout, try again? It's not a good experience, right? You don't
Yeah,
want to, you won't like it. You'll say, oh, this the website is like not working good. They're not doing, there's something wrong with that, and maybe you will lose money, and then yeah, it'll create more problem. That your payment
that
detected.
won't be a very good user experience, basically.
Yes, exactly. So that's why this messaging queue is used, and it's a very critical component of for any event-driven architecture or any other architecture where the multiple services are talking to each other. Okay, so in this, if you see some like a presentation, we can, and then they talk to it when they call it asynchronous communication. In this case, they call it asynchronous, is like they're not in real time talking to each other. Sometimes like they're talking to real time, but it's just there is a queuing holding the data in between. That's what helping uh, for the requests to process. So this is why if you see there this presentation, maybe they say event data source, like you put the order and then it get to publisher, and event data store is where the it's get queued, and subscriber is like where the data is went to. So you don't need to learn everything now. It's just to give you how the flow in this looks like. I think this one could be like better. There's lot, their diagrams are not very good. So we have, yeah, see, they say roadmap for microservice, event driven architecture, message driven architecture, and containerized application and platform. So they basically, event driven architecture is known as a message driven architecture pattern promoting to production, detecting consumption and reaction of events. So it's just based on event, any event happening. Uh, so in this one, what happened here? So if one service send the data, to another service, right? One will be like from and another will be to, right? When the two services are talking. So from which one we are sending the data is publisher, because you are sending the data is like publisher. You're
Okay.
publishing the data to this queue, messaging queue, and which will be receiving it is the consumer, because it will consume it. Just like
Okay.
how the naming is, you just have to remember it this way. And even if you will get confused, how do I remember this? And then you publisher and consumer, you just type it here. Because you don't need to have to go through one book only. You will always see that publisher is sending the packet to message broker. Message broker, queuing, they have like similar purpose. And then they're sending to
Okay.
consumer. They're showing like they're sending to multiple consumer, right? So they
Okay.
can send
Yeah.
it to multiple consumer, they can send it to one consumer. It depends what you want. So there in some cases, like when the uh, order happen, for example, and it's sent to payment service, and payment service will give the data to maybe order service also, which may be tracking the order and tracking service also. So it sometimes the application.
These all are communicating
Yeah,
simultaneously.
right. So it depends. Sometimes in cases, yeah, like you said, sometimes we have to send it to two services also. So what is the advantage of this message broker or queuing system in this case? The one case I told you is like uh, it avoids any like interruption happen in between, because in the case if the application need to commit to directly communicate with each other, like consumer will send request to publisher API, right? They'll directly talk to API, right? But here you don't need to care about that. The publisher side, if service is there, its role is just to send data to broker or queuing in the middle. And now if you're making any changes in the publisher side API, you don't need to care about if you need to make changes in the consumer side also, because consumer code was trying to get the data from publisher side, right? So if on the publisher side, if you are making API changes, you don't need to make any API changes on consumer side, which is good, right?
Yeah.
But
Okay.
did you have any confusion here?
No, no, not as of now. No, no confusion.
Okay. Yeah. So same way, if you're making any changes in the consumer side API, you only need to care about if they are talking to message broker only. And message broker is like just like a database thing. It hold the data. Yeah,
Fetching the data from publisher.
yeah. It hold the data for like some time. Usually we try want to keep it only for some time, and then so that there will be like a whole time. And then the other advantage is also message broker. We can add high availability in message broker similar to database, so that if message broker will keep the multiple copy of one request or data, so that if one is lost, it will have it on another one. So I'll send you this. So just for oh, sorry. Okay. So if we see, so now what is publisher, what is consumer, right?
Yeah.
And where message brokers hit in this. And if I say message broker, shy.
Message broker is kind of a middleware in
Yeah,
between the publisher and
yeah,
consumer, we can
exactly.
say.
When we say broker, real estate broker, what it does, buyer and seller. and it sits between buyer and seller. It does negotiating part. And similar here is our message broker for our messages that are going from, we can say, buyer
Pub,
seller
pub.
also, like you're buying a pizza and and seller is selling pizza, so that is working like a uh, message broker for,
Accountant, receptionist.
yeah, everyone can see those so many. And I
Yeah.
did search
Okay.
for message broker sharding here. You saw in that job description there was a term sharding, right? Even though it's for database, but sharding means almost similar thing for everything, for all these cases. So in sharding, if
Okay.
you check here, it's saying shard one, shard two, shard three. Now you will think, it is like replicating it. It is keeping multiple copy of it, and multiple copy on multiple servers. So
Yeah. Okay.
this way you get you have data more available. If one server is down, the data is in 2 and 3 also, and they can still communicate with each other. Like in another picture, they put message broker here, but basically it is in like in the middle here, like in communicating with, during communication with these services. They don't know how to put this here, so that's why they put it at the back, but it's basically in the middle.
But this
And
diagram is more confusing.
yeah, sometimes they just assumes the reader know this, so they just make it sometimes in a different way. So sharding also, we get the idea, right? And then there is a partitioning also. So partitioning is like one request is going, but it will split up into multiple requests uh, to make the order maybe, and it will divide basically the request into multiple. So to make it easy, we will see. We'll see the definition here, which will make it like more easy. Sharding versus partitioning. Sharding split the data across multiple database servers, which contains subset of the data. So every server has uh,
Uh,
so every server has some part of your data, and it's like basically divided into multiple data, right? Servers, right? And
Sharding basically it splits the data or it replicates it.
it replicate also, but uh, also store in different servers also to keep the multiple copy.
Okay, okay.
We'll
Basically,
go
it
with,
split and store it in multiple database as per at
yeah,
requested as the
maybe we'll
region.
study a little bit Kafka, and then it'll be more clear. But here for now is, it is used to distribute data to improve scalability. When it says is like, so they have like a sequence number or something for like in messaging queue or brokers. So when the message is going, it is like sending some, like your order data maybe to server one and some other one to server two. It, or maybe one request can, data is, if it's large, it can split up into two. But in that there is a replication factor also. If you keep it like two or three, it'll keep multiple copies based on that. So replication factor is what matters, is when the sharding is happening, how many copies to keep of it. So that can be like a correct statement to say. Okay.
Okay. Yeah.
And partitioning is to divide it into smaller subset, which was like, that's why I opened it, because they sound a little bit confusing. That's why I opened this term, because they can be confusing. Confusing is now the splitting the request into multiple part is partitioning, like making partition of 1 into 2 or 5 is that way. Maybe we can remember it, right? Partitioning is dividing.
Okay.
And dividing the same thing and sending across multiple servers is sharding.
Servers. Okay. Okay.
So when sharding is happening, partitioning will also happen. We can say that, right?
Yeah. Okay.
And then to decide how many copies we want to keep for each split up data or our data is depend on the replication factor. See, this is showing we can do this. See, number of copies of our topic. So now I'm not going to topic and everything because it'll get more confusing now. Okay. Because like all these things have different terminologies. So we don't need that. So topic, we can say, if we want to remember it, is just so for like, for example, for order. So just like in have you used here we have to store the data for every service, right? I was telling different services will talk to each other. You remember it?
Different.
Different services are talking to each other, like different services are talking to each other, right? And
Yeah.
for
Yeah.
that,
Yeah.
we are using our where is that? This messaging queue or message broker. Uh,
Okay.
so now like service A talking to B and B talking to C, they are different data, right? So to remember those different data, it will have a different topic name. So topic decide which services are those.
Okay.
You get the idea, right? Now what topic is. So I'll just mention to you. I think this will be enough for today because I think it'll get overwhelmed. Topic,
And
replication, uh, partitioning, and sharding. Okay. So one second. I I'll I'll restart the meeting. Okay. Just one second.
okay.
One second.